Hi everyone. Welcome to the Rez BoF for 2019. We're going to break this into 3 sections. So the first part's going to be an overview of how we've integrated Rez at Method Studios. The second part's going to be a roadmap for development. So it's going to talk about what's been done and what's coming up in the next year. And the last third will be a Q&A. So let's get started. So I'm Allan Johns. I'm a lead pipe dev at Method LA, and I wrote Rez. And my colleague who's doing the first part of the presentation is Steve Mackenzie. He's our lead pipe dev at Method New York, and he builds lots of stuff and resifies lots of stuff. Thank you to the Academy for making this happen, and specifically for sponsoring me to make this talk possible. First of all, I just want to start with a bit of a poll. So who's using Rez at their studio? Hands up. Cool. And so from those people, to what extent are you using it? So A, across most or all of production? Partially, like maybe one department or maybe just for building, or, you know. And testing or kind of beta phase. All right, and who's already reasonably familiar with Rez? Okay. All right, so very briefly, a history of the project. It started life at a studio in Sydney called Dr. D. It was called DID Config at the time. It was open sourced and renamed in 2012. The first version was really just the dependency solver written in Python with some bash stuck around it to get it to be useful in a practical way. There was then a version 2 rewrite that it was pretty much a complete rewrite that turned it into a full API, all written in Python, cross-platform, multiple shell support, and a Python-based package definition format, which changed things. So as you can see, there's a bit of a reasonable spike of activity just recently as well, so that's good. I'll now hand it over to Stephen to talk about how we integrated it at Method.
Everybody. So first of all, it's useful to ask the problem of like, just what does production even want out of their situation? Generally speaking, we have a variety of needs, things like I need to use 5 different versions of Maya or 5 different versions of Nuke. We also commonly come across the issue of how do we migrate operating systems in a sane way where we're stepping from Ubuntu to CentOS, or even subversions between like CentOS 7.2, 3, 4, kind of ways of versioning forward in a way that does not break the pipeline while people are working on it, a way we can do migrations in a stepwise manner. And as well as just to like essentially flexibility around our runtime environments so that when developers inevitably screw something up, we are able to quickly adapt to that situation. It's also becoming more common that we want to be able to plug on new renderers or different situations, workflow types into different environments and quickly and rapidly assemble a different workflow for a certain kind of production. Oh, I've got a feature that needs to use RenderMan, I've got a commercial, I'm using Redshift, whatever. Being able to split environments up and sort of add on optional functionalities onto your GCC dynamically has always been really helpful for us. And of course, production wants to be able to have low impact events whenever things are screwed up. So being able to have an artist be able to do something as simple as work as if it were yesterday before a pipeline screwed something up, then that's a level of adaptation that we can present to the user in a way that actually functions in a way that is completely dynamic to them. And just to be able to like optionally provide different plugins like I was talking about before, like not every Nuke that runs needs to use every licensed plugin in your facility, and maybe you want to be able to have compositors dynamically add something on. So essentially, runtime management. Just a little timeline for context about how Method used Rez for a long time. Sort of to 2015 and prior, we used a system of site suites where every single suite basically had a folder of context that would get up-versioned constantly. Somewhere around 15 to 16 in that range, we got to a point where it became obvious we needed to sort of have show suites on top of site suites so that we could have essentially like a show could override a specific tool set. And then what I'm going to talk about a little bit in more detail soon is something we've cobbled together called mconfig and mproduction, and that's got some implications down the line. Eventually, what this has given us is an ability to give artists essentially a command that is running their version of Maya or Nuke or whatever, but is dynamically resolving what they want at the exact time they ask for it. So there's no more staleness in terms of an artist opening something up and having a shell open for like a week and ending up like in some bad environment where maybe some service has been migrated and things are not functioning quite right. So it's to avoid a lot of those issues. And then I'll just very briefly outline a model we're moving to called our software deployment system, and that'll just have a slide at the end just for one thing. So generally, this is kind of our artist experience. At the simplest, we want it to be as simple as set your shot and be able to CD to something convenient and run your application. At its more complicated, we are exposing to artists a time flag with the ability to essentially turn on or off the visibility of packages that have been released. So as you know, Rez packages have a timestamp associated with them. So our set shot system can essentially inform Rez as to the -- time flag passed along. So if you walk in the morning on Tuesday when we've updated a whole bunch of packages, the artist experiences a break, Nuke's not launching, hey, what's going on? Okay, let me just set it to yesterday until the pipeline guys come in at their leisurely hour and start actually fixing things. It's also possible for us later on, I'll get into this unstable, previously stable bit, but essentially we have a concept called package views, which maps to a channel or a service-managed package path that is taking the raw package path of the studio and translating it into a specific sort of channel of packages that are being timed out in a specific way. And the artist has the ability to patch on existing tools, additional Rez packages into their environment dynamically because it's happening at tool launch time. And you'll notice the Nuke 10.5, as in Rez contexts from a long time ago, you are able to suffix your tools, so you're able to present as many versions of Nuke or Maya to the facility as you want. We usually take the step of making a certain default present, so in our case, like Nuke 11 is the default, so if you have to backpedal for some reason, you can run the Nuke 10.5 there. And on the flip side, as a developer, it's very helpful to be able to test in the production environment with your extra stuff. So we have some flags that essentially are, again, dynamically adding this in, but are allowing things like local packages to the developer, having sane ways of just quickly printing out the resolved package list to help debug. And at the very bottom, you'll see sort of typical things I find myself doing when debugging a resolve, pulling out the DCC's requests and starting to graph things, find the conflicts, be able to mess around with things a little bit that way. So just a brief overview for people that aren't terribly exposed to Rez all that much. A context is basically just a request that has been resolved and baked off. And so the way our even current core suite is handled is essentially just a system of having a folder full of contexts, and you're able to use the -- fetch command on a context to see what would update. So it's a fantastic preview device to say, what am I about to expose to my facility before I've gone and done it? So that's kind of a critical step when we're making sure we, it might be worth sending off a warning to production when like some very large new version of things with many dependencies is about to come in. It's like, okay guys, just so you know, like let us know if there's gonna be problems or whatever. And then the concept of a suite is basically, as I said, a whole bunch of contexts that are in a folder, and essentially just wrapping that fetch functionality, we can do something like just quickly query what all of these contexts are going to expose to the facility. And simply, as shown at the top there, where you're creating a context just to take a request and bake it out into a new one, that's really all you're doing with this -- update flag to basically actually take that fetched context and bake it back into the resolve. There's a little script somewhere called Soma that has some rich history at Method that essentially is wrapping even that process to say, all right, I'm going to create a version subfolder that takes copies of all the contexts and starts to bake out the tools present in the contexts out to a bin path in that structure. So essentially what we end up with down here at the bottom is a symlink pointing, two symlinks, one pointing to current, one pointing to latest, and so which we can manipulate if we have to, and just kind of symlink one thing to the other, if or backpedal a version. And what you expose to your path is this path to your current or latest, depending on what your attitude is, /bin, and that's where all your tools live. So that's just kind of like a super simple way to take a facility that doesn't use Rez yet and just kind of put on a very basic level of management around a very core set of tools that are being constantly used. With Method, we sort of came to the conclusion that managing individual show suites for literally hundreds of shows was untenable. So, we handle commercials, we handle features. So while in Vancouver, I might have 6, 10, 15 shows. In New York, I have a new one every week. So it's important to be able to not just be able to manage context in like one singular way, but also be able to manage them dynamically. So that's where we're going to head. So we have something called mconfig, mproduction, and fig. When you hear me saying mconfig and fig, it's really the same thing, but the mconfig is the disk-based version of this, and fig is the newer service-based model that we're currently in the middle of migrating onto. So just same concept, but one's completely RESTful and all of that, and then the other is just based on like grabbing YAML files off of disk. So, and a little look at the sort of simplified infrastructure of this. We really want to expose to our workstations and our render farm the exact same environments. So it's kind of important to just take a quick peek at how your overall infrastructure is and make sure that this is something that works. And very importantly, for optimization reasons, it's important to expose a memcached server to Rez because we're able to cache the resolves, and you'll see later on some metrics about exactly how much the caching is helping us out. And at the bottom here, I just want to really stress that we've got some replication of our files and our database stuff to other sites. So what's really neat about this system is I'm changing something in New York, and that same exact definition is changing in Vancouver and LA and everywhere else at the same exact time. So my entire facility is being upgraded just by changing one file in one location. Here's a look at the sort of illustrating the mproduction and mconfig system. So what mproduction is abstracting sort of methods configuration of file system in a way so that I provide shards of requirements to Rez in a way that I'm able to associate with the mproduction entity that my that my artist is using. So they're on a specific shot, on a specific job, in a specific task. Mproduction is kind of looking at the various places we configure this data, and in concert with Fig, which is actually performing the merge of this information, is presenting me with a final request that I've made. So every single one of our, at the facility level, at the show level, at the sequence and shot level, we're able to completely override any given request for any given tool that's being presented to the pipeline. So at the end of the day, what's happening is, again, the artist is running their nuke plus p key tools, and so it's merged together that request from our file system or from our service side, and presenting essentially to Rez one flattened request that is the result of the entity that they are in and the way that has found the fragments of YAML to merge together. So Rez, the resolve happens, the tool runs, and it's kind of also important to note that there's environment variables available to you in Rez that are going to pass into your DCCs that you can use then to guide the way that your render farm will eventually handle things. So we're passing in our timestamp of when the user did their MSS and passing in the request that's been used to the render farm so that the render farm can run exactly with the same code that the artist was using when they launched their application. So there's no schism. If someone launches a new release of something, it's not going to get into what the artist is using. This is just kind of a little overview of just like the simplicity of this configuration. So an example profile that is exposing these requirements and tools over on the left saying, oh, well, I need a version of OpenImage.io, I need a version of OpenColor.io, here are the tools that are exposed. The views.yaml is how we specify the suffixing, prefixing of any given set of tools. So you'll see that the Maya set of stuff has a default of Maya 2018 at the moment in the facility, and everything else has its own prefix, so you can access those individually. Also super helpfully, until the software deployment system we had is being moved to, we've used a system of locks that uses a cron syntax, which is essentially driving the res-t time flag so that new packages are only allowed into a resolve at a specific cron-like time. So for us, the one method we found to be super helpful was that on Tuesdays, Wednesdays, and Thursdays at 4 in the morning, new packages are allowed in from the previous cycle because things break on Friday, I have to get renders out for the weekend, and I need Monday to fix whatever went wrong on the weekend. And then from there, we also just have a little like a shard of this common YAML, which adds a request to every single profile that is in our system whatsoever. So we can put common things there or common constraints like weak requirements on something important like our review system that needs to be a common version across an entire production or across an entire facility. And just a brief note about the software deployment system we're moving to. So we have a method of taking a service-based approach to essentially maintaining a raw, unstable, pre-release, and stable set of packages where all the res builds go against a common raw set of packages that are just the base res repository. And then we essentially construct dummy packages that are copies or symlinks to those packages in a new location, point artists as far as their package path is to a specific package view or channel or however you want to think about it, and just kind of migrate this forward, giving pipeline the ability to promote and demote from these various channels so that by the time something gets to pre-release and into stable, it's already been vetted by a few key users that are identified TDs as people that are going to be working with this. So a couple of metrics that are just kind of nice to look at and interesting to think about when thinking about the volume of resolves that might happen. As we just said, our farm is performing a res resolve. It's not passing along an environment, it's passing along the recipe to rebuild the environment. So, sorry, I'm gonna get into a couple things here. So on average, we've got 8 requests in a profile and maximally 53. And in for tools listed in our profiles, on average, it's 3. And 27 is our max. I think that's our Houdini profiles. The packages in our resolves, generally speaking, our resolves have averaged out at about 109 packages per resolve, and the highest one I could find was Maya at 330, which is, as you'll see in the next slide, approximately a third of our ecosystem. So our Maya is a little bit heavy. This is the breakdown of how many packages we have built internally and externally, and you'll see that a huge portion of our external packages are individually packaged pip packages. Rez is more than happy to handle this level of volume and granularity. Of course, there are plenty of times where it's not worth packaging all the stuff individually. There are sometimes meta packages where someone's taken 10 pip requirements and just like shoved it into one package and calling it a day, because sometimes you just need to get it done. So this is the config system metrics that are worth seeing. It's worth keeping in mind that Fig is not just fielding res configuration requests, it's also fielding requests for every single packageable configuration attribute in our system. So, and this isn't even in full production yet. It's mostly in production in Vancouver right now. And so, for example, this is Vancouver metrics fielding 31 million config requests this is in a week. Here's a 7-day slice of our resolve metrics and a 60-hour slice below that of the same area where you can sort of see the heartbeat of our studio as people come online in mornings. This is showing that in one site at a time, we're peaking at about 25 resolves per second. Definitely a result of the render farm ability, but we're able to handle it just fine. And that comes up in the next little bit where we start looking at how resolves are cached and how long uncached resolves take. This particular graph is histograms of the maximum resolve time for an uncached resolve. Could be as high as 180 seconds in our facility. It's very rare, but it does happen. Like even if one resolve took a long time. So imagine what's happening if you're caching resolves. The first person to run nuke for the day is going to experience a little lag time, but then that resolve is now cached because that's when the package is changed, and now every other user of that package is essentially using the same resolve. On average, though, every uncached resolve is 3 to 7 seconds, depending on, this is a week worth of metric, and you'll see like the min for a given day is usually like 0 to 1 because there's just resolves that are blindingly fast. And here's a little bit of histogram of the ratio of caching. So you'll see on the right with the pie chart that we're achieving a little bit. This fluctuates a little bit, but generally no more than 2% of resolves are uncached at any given time, and that's taking into account that artists are doing things like patching on a specific plugin or altering things a little bit slightly. And you'll see at the very bottom that we're pulling 500,000 resolves in a day, only 7 of which are uncached. So generally speaking, this is a tremendous benefit. And you'll remember back here when I said there was the max of 180. Well, in the top right, what we're seeing is that in this week, only 25 resolves took more than 60 seconds, and 5 took more than 120. So essentially, like, the number of slow resolves is extremely small, and probably that was because someone was resolving something that was uncached on a bogged down host that was not doing something terribly happy. So just worth keeping in mind. And on the left is just a histogram of how many seconds each resolve is taken. We're also doing a lot of metrics-based gathering. So here we've got a breakdown of which packages were used in resolves at that point in time, and we treat this very granularly. We can even do it by package version. So we're able to sort of keep eyeballs on asking questions like, how far are we to migrating onto a new version of something? What's our ability to be able to introspect into what artists are actually using, look at versions of things that have problems, associate this with other metrics in our systems that are, logging errors and seeing how we can move forward in our ecosystems in order to push further into, say Python 3 usage and that kind of thing. You'll notice Python 2.7 is our top used Python. Failed solves in a week, 78 out of 3.8 million. It's pretty rare, so usually just developers. So just really good to have this level of confidence in your system that, generally speaking, there aren't a ton of artists trying to run a tool and failing. And just a little fun, that's our Maya graph, just couldn't help myself. Next up, so just a couple quick bits of advice, things we found useful. In general, we find it super helpful to externalize our licensing details to some kind of the package needs the license, but you don't need to read the license from the package. You can read the license from some file outside. So it's good to manage that separately and not assign license servers into packages and then have to re-release something arbitrarily, just kind of a little silly. We find it's common to see that as a first pattern that people use, and they're like, oh, why can't I change my package on the fly and then expect everything to work well? As well as adaptive packages, here's a sort of reactionary approach that a package is taking to the presence of other packages in the resolve. So it can be useful to do things like check if your resolve has Maya in it and react accordingly, present certain plugin paths, and that way you can present just one variant or one mega variant of something that has a lot of components if need be, and simply add on features in a way, and that's something that is going to get expounded on more with Allan's work. We often get asked things about, what about configuration management? What about details that have to do with, say, you want to alter something in a task-based way that somehow ties together with a package. And the way our system works, it's not always transparent to be able to do that, but one thing that we found useful is Rez has in its commands section, has a command directive that can be used that injects things into the context SH file that's generated to produce the resolve for the user. We've used a tool that basically at that point in time will look at the environment and react accordingly and do things essentially abstracting our task system and using the exact same configuration methodology as the end production stuff, where I can set context of show, shot, whatever, all this stuff, and sort of drill down and say, if Maya is in the environment and if the task is animation, maybe I want to disable OCIO, and it just turns it off. So I find it wise to try to find a way to abstract what you might consider to be configuration management for yourself. Problems we experience, we get mutual exclusivity issues where a good example would be for USD, we build a Katana variant and a Maya variant because we haven't quite broken it down into sub-packages yet. And then essentially we might have a resolve that actually has both Maya and Katana in the environment for some other exotic reasons, and Rez is going to pick one and can't be using two variants at the same time. So that's a problem for us occasionally. Thankfully, I think we have a solution for that on the way. It's also hard to set up build chains that do things in a useful way when you want to clarify whether something is a release build or a debug build, pass that to CMake, be able to build multiple build chains, one that's your debug build chain and one that's your release build chain. You can kind of do it with like sort of dummy packages that you use to alter your resolve, but it gets cumbersome and extends file paths a little too long for comfort and so on. Similarly, lack of negations and variants is definitely an issue for us right now, where I may want to exclude everything in a specific variant, and it's just not really possible to do that because file paths don't like exclamation marks all that well, or our shells don't at least. Configuration management, I was already going into that a little bit, so I'll skip over that. It's a common complaint with our system engineers that storing all of our packages on central file servers is a huge burden of I/O, and querying these packages and pulling data together actually contributes to the overall load of the system. We've started looking at localization strategies. I'm led to believe, I think that's something that a couple studios are doing, where they're localizing packages to their hosts. We'll have something to say about that. Common thing is kind of the question of how far do you take this? Where do you stop when you're trying to resolve dependencies, when you're trying to make packages? We've definitely made the mistake of going too far at times, where like we've gone so far back in system level dependencies that it became unwieldy on its own. So it's good to like have talks with your system engineers and think about your use cases and how much exactly you need to represent in dependencies. What do you actually need multiple versions of in production? And what's provided by your operating system in a really clean way. And yeah, we're looking at how to do some performance testing with the Rez tests themselves. I don't mean Rez test in the packages. And once in a while, like something weird happens with our resolve, and it's kind of hard to debug when a backpedal happens, when some new requirement is added, and it backpedals your entire resolve like a huge distance back to some really older set of stuff. It'd be nice to have something that could detect situations like that. And with that, I'll pass it over to Allan.
Thanks, Stephen. Okay, so now I'm going to talk about where we're going in terms of development with Rez. So we've introduced this new idea on the GitHub project of reps. We've kind of stolen the idea of PEPs, the Rez enhancement proposals. They're kind of analogous to epics in Agile, so they'll describe a sub-project within the Rez project and attempt to break it down into the tasks required to implement it. And they're labeled as rep in the issues in GitHub. We have 3 reps at the moment. We've got one based on some enhancements to Rez tests, which I won't cover right now. It's a fairly minor point. Rep 002 is the main one that I'll talk a lot about, and that's getting us to the point where, well, I'll explain it in a sec, but it's called recipe repositories. And Rep 03, which I'll talk about now, is something called package and context localization. So localized means removing the need for external resources, and by that I mean when you create a context by running resm or doing whatever you want to do, there's currently 2 external resources you typically need. You need to access memcached in order to pull down the entire package definition to get the commands to configure the environment. And you also typically need access over NFS to get to the package installation. And as Stephen already mentioned, that can be problematic and put a lot of load on the filer. So why localize? There's 2 reasons. One, as I just mentioned, is to speed things up with regards to performance and stop hitting the filer so much. But the other reason is because you might want some sort of standalone installation, particularly for services, for example. So this is what happens currently. You create a context, and in a context it contains these things called variant handles, which are small metadata dictionaries that give enough information to be able to fetch the entire package definition. When you source one of those contexts, it will then create the resolved environment. And a process running inside that environment is typically going to hit NFS in order to pull down Python source files. So by localizing both of those things, you remove any externalities. So the package definitions themselves end up completely embedded into the context, which just results in a larger JSON file, basically. And the process that you run will end up hitting package payloads that are actually on the local disk instead. To give you fine-grained control, there'll be a new tool that does this, that allows you to do this. And I've got some examples here. So you may have an existing context and you want to then populate a localized package cache with its variants. So you'd be able to do that. You'd be able to just introspect the cache directly. you'd be able to create a context and explicitly associate that context with a given cache. You might want to modify an existing cache and associate it with a different cache, a context, sorry, and associate it with a different cache. Or you might want to source an existing context and override whatever cache it had already specified, if any. So those are just some examples. This is a more interesting case where you want to create a context that's entirely standalone. So this example would create a directory that contains both the context and all of the variants that context refers to. You would then literally be able to just copy that onto a server or into an image or something, into a containerized situation, and have something running completely standalone. The only prerequisite you need at that point is that Rez would have to be installed on the target system. Okay, now onto the main point, which is something called recipe repositories, sorry. So one of the biggest goals from Rez from the start has been to be able to install packages from public repositories, much in the same way that something like pip can. Right now, studios do spend a lot of time having to build their own packages and what we call resify packages. As a result, there's not really any sharing of package definitions across studios or the build code associated with those, and there's no standardization either in terms of what particular variants might get created for a given package, for example. And so we're going to introduce a new tool called Rez-install, and that will install the package and its dependencies, and also give you control over the build configurations as well. I'm going to show you how that is theoretically going to work. So you can already write reusable package definitions that build third-party software to an extent. It's helped a lot by the fact that package definition files right now are quite programmatic. You have early and late bound requirements, early and late bound attributes that allow you to define something like the requires section of a package as a function, and that's very, very useful. But we need to build on that. So the problems at the moment is no dependency tracking. Rez build, which is the tool you use to build a package, or Rez-install, doesn't determine and build and install dependencies, and shouldn't. It's never been its job. There's no build configuration support in the sense that you can hack around, but it's quite difficult to say, well, I want to build a debug version of this package and release it as such, and then have some other package or person consume that package, specifying that they want that particular build type. So here's an example of what Rez-install will probably look like, and I've just used OpenVDB here as an example. So you would pull down what's going to be called it's a recipe. And recipes just contain standard package definitions, exactly the same as you'd have when you build your package.py, it's no different. But they reside on a different search path, which is defined by Rez recipes path rather than Rez packages path, to inform Rez that they haven't been built yet. And so it should expect some things in that package definition that it wouldn't see in released packages. And then it's going to go through and find some packages that need to be built and do that in the right order, and perhaps some that don't because they're already installed at the studio. So yeah, I already explained, I think, a lot of this just now. Packages can exist in recipe repositories. So they're standard package definitions, but what they do is they programmatically construct a single variant to be installed, and that'll make a bit more sense in a second. What it then does, in order to determine what packages, what dependencies need to be built, it actually will perform a standard resolve across both the recipe repositories and whatever existing package repositories you have. And then when you get the result of that resolve and you go up in reverse dependency order, that actually tells you what packages need to be built in order to satisfy all the requirements. So here's what it looks like graphically. Rez-install A, so we want to install A. It does a resolve. The graph there shows you the resulting resolve. And the green ones are the ones that have come from recipe repositories, and so they're packages that haven't been built yet. So we then just traverse the graph from bottom to top, and we build DNA in this case. So package features are a crucial part of this. This doesn't exist yet. It's a way for packages to describe their properties, and so for example, you might model the build mode of a package that if it was built as a debug or release, you describe that as a package, which would be some information that's now available at runtime from that package definition. Features are listed in variants, much like normal requirements, and both users or packages that request packages can request them via their features, and I'll show you how that works in a second. If a package feature is asked for, then only packages with that feature can be returned, can match the request. And they're based on something else that I'll explain in a second called ephemeral packages. So here's an example. Let's say you want version 1 or greater of some package foo, but you want it to be built in debug mode. Sorry, you want to retrieve the version of foo that was built in debug mode. This is what that will look like. So rez-m foo1 plus, which everyone will be very familiar with, but then you have this kind of odd syntax here, which I'll explain shortly, and this is actually requesting a feature. The feature in this case is the fact that foo was built in debug mode. So ephemeral packages are packages that don't exist, which sounds odd, but they'll be very useful. They start with a dot. Currently, packages can't start with a dot, so that works out nicely because there won't be any clashing. They behave the same way as standard packages, but they never resolve to a version because they don't exist. And it turns out there's a few different ways we can use these that turn out to be quite useful. One of them is to model a requirement of a package that is a bit of an abstract concept. It's not actually a package. And an example that you could use to describe this is the platform, the current platform. So for example, platform Linux, it's an ephemeral thing. You don't necessarily need to configure something in the environment to reflect that depending on what your setup is. It turns out also that you can use ephemerals as a general way to pass information to packages so that they can change their definitions or change their behavior. And when they're used this way, they're called a package option, but there's nothing special about them besides that. And the last point is that they also form the basis for package features. So here's an example of a package option. We have some package here, and what it's going to do is it's going to check to see if an ephemeral is in the request called foo.cli, and if it falls within the version range 0. And if it does, then it's going to take that to mean, well, I shouldn't make my binaries available on path. And then a user can simply put that option in, and you won't get those command line tools. Bear in mind also that packages would also be able to do this. Like everything else with requests in Rez, there's no difference between what you can do as somebody using rez-m and what a package can do when it's requesting other packages. So it's all quite homogeneous. So using ephemerals as the basis for package options and features actually avoids a lot of extra complexity. There's a lot of the behavior of packages that match the behavior of what we want to see in these cases. And it just means a lot of extra stuff in the code doesn't need to be added, so it just avoids complexity. But it does also look a bit weird. So we're going to support some new syntaxes. So you can see here with a slash, that's going to specify an option, and a colon will specify a feature. So here's a full example recipe. It's OpenVDB. I've made it really, really simple for display purposes. And I'll just run through it now. So getDebug is just a utility function that would get stripped when the package is released. It's just figuring out if the debug feature has been asked for and sets it to 0 or 1 accordingly, and defaults to 0, meaning you generally want to release a non-debug package. The crucial part of this is the variants section, which is dynamically defining the requirements of this package as a response to a rez-install request. So it has a bunch of packages in the list which are standard, so it always requires boost, Allan base, and OpenEXR, and avoids a particular version of OpenEXR. But then what it does as well is it checks what the debug feature should be, and then sets that feature into its own requirements in response to the request from the user who's run rez-install. So it's adapting to what's been asked for by the installer. And lastly, just as a point here, I've shown just an example scenario where it may be true that if OpenVDB is getting built in debug mode, then it also wants access to a debug build of boost. That's just by way of example. Okay, I've already explained packages dynamically construct variants to respond to the request. A problem that this raises is that you're going to get really weird long variants that are not necessarily POSIX compliant or will probably screw up build systems and shells. So we have something new. These are called hashed variants. Hashed variants are already implemented, And they do away with the full variant installation path, which up till now has been based on the requirements of the variant. And instead, they base it on a hash. Now, what you see here is not a hash. It's something else called a short link. And a short link is just another process in the release that goes through and just creates a very short version, which is a symlink to the hash, and does it in a way that's not going to cause conflicts within that already released package. To do that, you just add this new attribute called hashed variance. You set it to true, and Bob's your uncle. We have a new type of requirements expansion. So what this is, oftentimes you'll have a package that before it has been built is compatible with some larger number of versions of a package, but then after it's built and compiled and linked against whatever that is, then that turns into a hardened requirement. And so you can currently express that, but it doesn't work too well. There's a few problems with it. The syntax is too limiting, and that expansion happens too early. So I'm planning on replacing that completely with a new syntax and a new system. The // is something called a request directive. It'll indicate that what's there is some kind of modifier that alters the request at some point. Provides functionality is something that has been thought about for a long time. It's a specialization of package features, and it's a way for a package to tell other packages that it also provides another package. The classic case being a DCC that comes with Python. What it will do is, if the native version of that package is also present in a resolve, it will effectively override it and will remove that package's ability to configure the environment. And here we have an example of Maya expressing to other packages that it actually already provides Python. This one's really interesting. So Stephen mentioned already that we have issues where there are cases where we can't reliably guarantee that a particular variant of a package will be chosen. Even though the rules that do choose a variant are completely deterministic, it can be very hard to tell why your Maya variant wasn't chosen and instead your Houdini one was, or your variant that actually doesn't have a DCC was chosen. So the way that we can solve that, which is kind of neat, is to consider all the requirements of a package as being features unto themselves. And because now we can actually request package features, we now have a way to say explicitly, well, I want a version of foo in this example shown here that actually requires Houdini. And so now you've struck that down to only be able to select those variants that match that request. The end goal of all this is to be able to install anything easily from the VFX reference platform, which is where we'd really like to get to sometime next year, with full control over the build configurations that you would need in order to do that. And one example of how this would be used in practice is that we'd also have a VFX reference platform package, which just acts as like a bundle. It would just be a big list of weak package references that just limit versions. And here's an example of how you'd rez-install USD. Specifically saying that you want to install the Maya plugin for USD. The --env is something I haven't really touched on, but it's basically something that will be added to Rez build as well and Rez release, and it's just a way of narrowing the build environment. So in this case, by adding VFX reference platform to the environment, to the build environment, you will in effect be limiting the versions of USD to whatever the reference platform has specified. So you don't have to know what that version is. You just reference the reference platform. Loads more detail about everything I've just talked about are available on the rep 002 ticket on the GitHub project, and the link's there. It should be easy to find. Other stuff, we're in the middle of a Python 3 port at the moment. It's coming along. It should be ready, I think, reasonably soon. Python 2 will be supported at the same time. You will not be forced to use Python 3 once that version of Rez is released. The installer for Rez itself has been updated. I won't get into details, but it's modernized now, and it's all going fine. A whole bunch of Windows fixes, a new shell was added, PowerShell support was added. There's been a lot of work done on rez-pip, which is the integration tool that allows us to install pip and a pip package converted to Rez packages. Lots and lots and lots of pip packages can be reliably installed this way. It also more correctly generates the matching variants in a Rez package analogous to the pip package. So, for example, if a pip package is pure Python, then it won't variant on platform architecture and operating system, for example. It does some more things of that, though, and takes into account things in pip called environment markers, which if you're a Python packaging geek, you'll know about. Pip extras aren't supported yet because they don't fit into the model of Rez at the moment, but when package features are there, they will, and it should be fairly trivial to support them at that point in time. Further work, just very briefly, further things that we can do, resolver optimizations, that will have to come. I suspect that as a result of this kind of stuff I've just talked about, that you would tend to see more packages and more variants on the go in any given solve, and so it's possible that will cause solve times to blow out further. Fortunately, I think there's a lot of room for optimization still, so that's good. In order to optimize, you need to know how long solves take, and it's very difficult to do that right now because they can vary a lot from one solve to another. So we really need a benchmarking suite, and I'd quite like to take our suite of packages from method and anonymize it and put it into one big repo and have a whole bunch of resolves. You can graph out the results, and then you can really see what differences occur. Shorter Python path, so long Python path is a big deal. I won't get into it now because I'm running out of time, but we've got that in mind. And better environment variable management, but I'm going to stop there because we need to have some Q&A. Governance is changing. I've been BDFL, and it would be good to change that because it's becoming too much work, and I really want to keep the project moving forward. A small group of collaborators have actually been added as of now, but I am open to a new governance model in the coming year. Anyone who wants to get involved, please do. There's 17 tickets listed on Repo 2 already, so that probably means there's loads more. Thank you to all contributors. Any questions?